Assalamu alaikum. My name is Aqsa, roll number 21TE08. Today we are diving into the fascinating world of digital signal processing right there. In this lab, I have got a bunch of tasks lined up that showcase the magic of digital signal processing and how it plays a crucial role in various applications.
From the task 1, which is entering the starting points and the limit. In line number 1, n0 is equals to minus 1. This line initiates the variable n0 to the value minus 1, n1 is equals to minus 3. This line initiates the variable n1 is equals to the value minus 3, and n2 initiates the value is equals to positive 3. In line number 4, this line creates a vector n containing integers from n1 to n2. In this case, n will be minus 3, minus 2, minus 1, 0, 1, 2, 3, forming an array. In line number 5, this line creates a binary signal x, where each element is 1 if the corresponding element of n is greater than or equal to n0 or 0. And in last, this command creates a stem plot where the values of x are plotted against the corresponding values of n. And here's the resulting output. Moving forward to the task 2, this line also initiates the value n0 is to the value of 1, n1 to the value minus 5, and n2 to the value 5. And this line creates a vector n containing integers from n1 to n2. In this case, n will be minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and 5. And x is equals to n minus n0 is equals to 0. This line creates a binary signal x, where each element is 1 if the corresponding element of n is equals to n0 and 0. And at the last, this line creates a stem plot where the values of x are plotted against the corresponding values of m. And the resulting output is this. In the task 3, same as task 1 and 2, this line initiates the variable n1 is equals to minus 3, and n2 initiates the variable n2 is equals to 3. And this line creates a vector n containing the integer n1 and n2. And in line number 5, this line calculates the value of the origin x for each value of n using the formula x is equals to 3 cross 0.5 raised to power n. This is an exponential decay for which each subsequent value of x decreases by a factor of half compared to the previous one. At the last, this command creates a steam plot where the value of x are plotted against the corresponding value of n. And the resulting output of both the codes are this, forming the discrete signals. Task 4 is the function impulse sequence. Create a function impulse sequence that is equals to unit impulse sequence and values. The unit impulse sequence generates a unit impulse sequence. Unit impulse sequence is equals to unit impulse sequence generates a unit impulse. The sequence of n is specified by n values. Now moving through the code. Here n values is equals to minus 5 ratio 5. This line defines a range of indices n values from minus 5 to 5 with an argument n value. In line number 2, this line calls a function unit impulse function with an argument n value. In line number 3, this command creates a steam plot where the values of the impulse sequences are plotted against the corresponding values of n values. In line number 4, this line sets the label for the x-axis, and this line sets the labels for the y-axis and give them a title. And the resulting output of unit impulse sequence is this. In task number 5, again make a function unit step sequence n values. Unit step sequence creates a unit step sequence, and the resulting code is this. Again, this line creates a range of indices and values from minus 5 to 5. These indices represent the discrete time points at which the step sequence will be evaluated. Generate the unit step sequence. This is a commanding indicating the purpose of the subsequent code. Now plot the values, plot and stem the n values and the step sequences. And this is x label, y label, and give them a title, and the resulting output is unit step sequence is this. In task 6, create a function named as flip signal, and the code is this is a signal which contains the value 1, 2, 3, 4, and 5, which represents the original signal that will be flipped. And the flipped signal is equals to flip signal. This line calls a flip signal with the argument signal. This function flips the order of element in the input array signal and returns the result, which is assigned to the variable flip signal. Display the original signal and flip signal. This display commands displays the string original signal, display the flip signal, and the resulting output is this. This is the original signal, and we flip the signal, and the signal will be flipped in the reverse direction, like 5, 4, 3, 2, and 1. In task number 7, create a function scaled signal, index scaling scales of the index of the given signal. This line defines an array signal containing the value of 1, 2, 3, 4, and 5.